Hello everyone, welcome to the last session slot of the day. You guys have been so good all day listening to lots and lots of talks. Now it's my turn. And I of course get to say the classic phrase, I'm the person standing between you and beer. So I'm not going to promise to be brief because beer won't be served until after last session anyway, so you're stuck with me. This is a new topic. I'm a little bit excited about this topic. I've never presented this topic before. I hope that it's going to go, well. I guess I'll see outside. But if, there's a party tonight, find me with a beer, preferably, and we'll talk about it and tell me what, was good or not so good. It's going to be fun because this is a very ambitious title, right? It's like practical design patterns in the age of very ambitious. It might as well be called Magnus rants about cloud for 60 minutes. It could be that because it's the same thing really. Because I have some perspectives on this and I'm going to share them with you. So in the cloud, right? You have all the opportunities of succeeding, of doing great things, and to fail in all the old ways plus some new ones, right? And in the cloud, you can deploy anything, anywhere at any time. And the topic we're not going to talk much about today is this. In fact, this word works like a little incantation. You have to always say it 3 times, okay? Preferably maybe click your heels as well for a good measure. But you have to say automation, 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 otherwise it won't work, okay? Just so you know. If it doesn't work, that's why you didn't say it right. Anyways, in the cloud, you have this unlimited compute power until you get your credit card statement. So there are reasons why we want to do this well. I want to start by asking you guys, this is, well, I know I'm not Satya, but this is from Build, I think, the audience. Do you have something deployed into a cloud which is in production? Hands up. That is a large portion of this room. I would say it's a majority of the room, which is very interesting. That number keeps going up. So I have been around the cloud for a good long time. I started out when they announced, I was fortunate to be in the audience when they announced Windows Azure. That's a PDC conference in 2006. And I went home from there immediately, and I've been talking about cloud, public speaking about cloud since then. And I've been working with cloud since then. So it means that I have done this for more than a decade. And that feels great now when everything from Microsoft is Azure. All the products that don't actually have Azure in the name, they rename them to something Azure, right? So it's cool. I was the first one to become an MVP for Azure in the Nordic countries. So I was there from the beginning. And I'm also what Microsoft call a regional director, which is a little bit funny because I don't work at Microsoft. I run my own company, Loftysoft. That's my company. I don't work for Microsoft, I don't have a region, and I don't direct anything. But it means that I'm a buddy of Microsoft. I hang out with them, and we have lots of fun together. I actually get to talk to Microsoft more on a VP level, which is so cool. Thing I like to do, has anyone participated in a global Azure bootcamp? Anyone? There's one? Just one? Oh my God, just one. That's great, because there's probably going to be some global Azure Bootcamp locations here in Australia for this year. Every year we do this, and I'm one of the people that kind of hang out and sort of administrate. I don't take credit for what all the great work that all community leaders around the world do. But I believe it was around 280-something locations, more than 15,000 attending last year at this global event. We do hashtag Global Azure, and it's trending around the world. It's fantastic. So we're going to do that again this year, and we will announce, I said I was going to Ignite, right? So I'm going to Ignite after, in fact, tomorrow. And we will announce at Ignite when the date will be for Global Azure Bootcamp for the next version. I kind of have to talk about that, right? It's a thing. I love doing community stuff around the world. Just to set expectations about this talk, I told you about ranting, right? I use the term pattern very loosely here. It's not very strict at all. I will talk strictly about, so here's a pattern, and here's what we did with that pattern to, help us with the thing we built. But I'm also going to talk about other things. So really, it's good to know about Azure advice dispensed by one who was there. But you know what they say about advice, right? Advice is a form of nostalgia. Dispensing it is a way of fishing it out from the past, from the disposal, wiping it off, painting over the ugly parts, and recycling it for more than it's worth. So that's what I'm going to do now. Basically, it looks like you're migrating to the cloud. Would you like some help with that? I think every presentation has to have Clippy, don't you? I think he does. Has to be here. But this is what the cloud looks like. And I use this as an old slide. Microsoft has stopped using this slide, but I keep it as sort of to give you a picture, right? This kind of a slide, whenever you see that, it's supposed to give you the impression that, oh my gosh, there's a lot. It's even an old slide. It says 36 Azure regions. It's like 52 now, right? And growing, or some 54, I don't know. It just keeps growing, no more and more Azure regions. But this slide is supposed to give you this, wow, okay, there's so many services in the Azure platform, I can't believe it. And yes, that's true. So I figured we'd figure out how many are there right now. Let me see, let me make this a little larger. There's a very, very simple way to find out. You just have to go to Azure and say, Azure, I'd like you to get me all the providers that I can use. Oh, you just saw the number. Anyway, there, all the providers. It's a long list. Most of them are from Microsoft, Microsoft dot something, but there are a bunch of providers that are not Microsoft providers. Here you go, Cloudin, Dynatrace, and things. And then let's figure out how many there are, and I already showed you. There's 150 resource providers in Azure. And some of them have multiple services. So there's plenty of things in the Azure platform, lots, and growing. That number keeps going up. 150 is a good round number, but they're not stopping there. There's more coming. So that's how much there is. And now it's time for a little check-in here. How many can identify this architecture? What are we deploying when we deploy this? You know. What is this? Yes. Oh, true. But there's a special, okay, I'll be clearer. There's a special service in Azure which Microsoft showed with this architecture. Anyone know? This is a cloud service. This was the first thing you could deploy in Azure when they announced Windows Azure, was a platform service called a cloud service. It's a very simple thing. You had a load balancer and some web roles, and if you wanted to have background workers, you would spin up other servers to do that job. And then the only way, actually, initially the only way to communicate between the two was to enqueue a message and have the worker dequeue them and work on them. That was it. That was basically, this is Azure, right, when it was announced. We've come quite far since then, let's put it that way. For instance, now we have web apps, app services that you can deploy. Those are great. Do you know, by chance, what they run upon? So in case you didn't know that, Microsoft runs scores of machines, lots and lots of servers running on the cloud service deployment. And they use that deployment to then allow you to provision your web applications onto these boxes. That's how it works, I'm just saying. Pretty cool. Now, I'm going to start with a bit of a rant. I'm going to start to talk about the thing that people always do last and mostly get wrong or don't do at all. And it's not really a pattern, but maybe it's the best practice that I could give you, if any advice at all. And that is to take a look at this guy, Azure Monitor. The last thing people do is okay, so now we have this service. Now it runs, we've deployed it, we're in production, it works. It seems to be at a bit of a snafu here. Let's see if we can figure out what it does. And yeah, then you haven't really thought about, or most people, right? Not you, sorry. Most other people who are not in this room, they would have thought, we can add monitoring and diagnostics and that stuff later, right? We'll do it later, no problem. That's the problem. So the thing about Azure is that it is a measured service. And what do I mean when I say that? Well, obviously, if you use it, you pay for it. You're going to get a very granular bill every month. You know this, right? It says specifically exactly how many bits and bytes and CPU cycles, and here's the charge for that, right? Exactly. So that doesn't sound good. But it is. It's very good. What's your response if somebody measures you a lot? What do? You also measure you. That's what you do. There's a great quote, which I want you guys to have, from Dr. H. James Harrington, that I love, which is the perfect quote for this space. Measurement is the first step that leads to control and eventually to improvement. If you can't measure something, you can't understand it. If you can't understand it, you can't control it. And if you can't control it, you can't improve it. Or, as the tailor puts, oh, you want a photo of that? Go for it. As the tailor puts it, you measure twice, then cut, right? That's how you do it. Except most people don't do it that way. I've seen so many client scenarios you can't believe. I've come into like a customer, I was there, I told them about Azure and I showed them stuff, and now, yeah, we're going to build stuff, go away, Magnus. And they call me a couple of years later and they literally ask me, what are we going to do? We have a performance problem. Customers say the service is slow. And I'm like, okay, how slow? And they're like, well, we don't exactly measure that. And I'm okay. Why are we having this conversation? So in Azure, Microsoft is putting a lot of emphasis on what the thing they call the, let's go to Azure. Here we are in Azure. A lot of emphasis on the thing that they call the, hey, I want it to be full screen. I like full screen. There we go. Emphasis on this thing called monitor. I put it up top. It's like a little speedometer thing, a little gauge. You click on that and you come into monitor. Okay, so Microsoft is putting a lot of emphasis on this. They're trying to pull together, or they are not trying, they are in fact pulling together all kinds of things, logs and metrics, one place for you to configure all of your alerts and things. If you never have been on this page, you're not doing it right. I'm sorry to say, but you have to be on this page when you're doing Azure. And here's a bunch of getting started, tutorials and demos, and all these things. And I come off as a bad, as a poor sales rep for Microsoft when I talk like this. I realize it, but I don't care. I cannot tell you, like, there's always the scenario that people don't measure well. They don't measure nearly as well as they have, as they could. And basically that's my first rant, okay? I think I might leave that now, but I think and I hope that you get the picture here, how important monitoring really is. Every service in Azure has diagnostic settings. Have you turned them all on at all? Most people do not. They don't even know how to turn them on. Okay? The diagnostics is there, but they're not using them. So when I work with all kinds of companies, small, large, what unites them is that they want to go to Azure in some way, shape, or form. A couple of things that I've picked up here in terms of good practices when we're talking about the monitoring angle. You should apply the principle of least privilege, as in don't let everyone just roam around your services and change things, because you will be very confused about which is sending diagnostics to what, and that can be mitigated by simply not letting anyone in. There's a good setting called a reader. Give that to everyone. Everyone can see what you're doing, but nobody can change stuff. That's a good setting. Basically only the deployment server is allowed to deploy things. That would be cool. Most people are not that strict, but it's a good thing to be. And then of course you have this monitoring capability. You get all the data pulled into just one place, and anything that you can find in the monitoring, in the diagnostics, in the logs, if it's a performance counter, if it's anything that you can find in there, you can make an alert on. So you find something wrong, well then you can go and configure some alerts on that. And that can call a webhook, that can send you an email or a text message or whatever it is. That's really important to do. So I already said, for every diagnostic service there is for every service there is a diagnostic setting. And the last one is actually incredibly important. Many times it's like the IT department are doing their thing and they're deploying stuff and they're setting up new services, and we need a new environment, and they're doing that. And I'm sure they're doing all things really, really thoroughly, but there's no one with a budget responsibility there, basically. All of that IT stuff is just a cost. And then what happens much, much later, the bean counters, the men in suits or women in dresses or whatever that is, they come running, right? They go like, okay, so this Azure thing, we're spending about $100,000 a month on this now. Could you maybe please tell me what is it that we're spending it on? and it's getting much, right? It's getting expensive. So what you should be doing, which is a difficult place to come to, is to make somebody, a person, it's always Dave, but Dave, bloody Dave, make somebody responsible. It doesn't have to be a person. Could be a team lead or somebody, but it could also be like the whole team is responsible for it. But anyway, at the end of the day, there needs to be a budget. There needs to be a number. Because otherwise, people are not super interested or focused on how well the services we deploy actually perform on the resources that we have deployed. And when they don't perform well, what are they going to do? They're going to add more services. They're going to add more cost. If there is somebody with a budget responsibility, that somebody will say, hey, wait a minute. Maybe we spend some time actually making the code better, figuring out if we can run this on fewer instances. And what's the only way to figure out if we can run it on fewer instances? Implement monitoring. Aha! So that's actually super important. Figure that, right? All right. So rant, it took a long time to rant about that. I'm not even sorry, not in the least. But let's talk about a pattern. Let's go real pattern now, okay? That's why you're here. The throttle pattern, super important. So Microsoft Pictures is like this. And I gotta say, you need to spend some time to decipher this picture. I don't think it's very good, so we'll put it in, parentheses. I'm sure we can figure out something better here. I'll give you an example. We had an example of an API that we had let partners use our API, and so they were able to call our API actually to send emails. And normally we send about 200 to 500 emails per day, in that range, so small number of emails. And then we had a spike. We had a really bad abuser guy who sent over 300,000 emails in a matter of a few hours. And the problem with that was that, first of all, he stopped all of the other legitimate emails from going out, and effectively gave us a production-level DOS attack. So our emailing service was disengaged. We had to go and unravel all of that. The one thing that was funny, though, a little bit of a payback, was that he sent himself so many emails that he brought his own email server down at the company. And they started to refusing his emails, and he got in a lot of trouble internally at his company. We're like, yes, that's awesome. But bottom line is that we were getting blacklisted. Email servers around the world didn't like us anymore because we're spammers. So that's terrible, which means that you have to understand that if you have an API that somebody can use, they will abuse it. It will happen. It's just a matter of time. So any time that you have something like that, you should be definitely defensive and implement. There's a classic pattern, throttle. You implement it so that you're able to say, hey, wait a minute. You have sent 800 emails today. No more. That's it, right? Some way to stop this. And if you haven't put this in your code yet, it's only a matter of time before that will happen to you, the thing that happened to us, right? So please don't go there. Take this or heed this advice. And definitely when this happens to you, collect data on this abuse so that you can have numbers. We were able to send pretty detailed screenshots. We didn't collect it. We learned as well. We didn't collect it the right way, but we were able to send pretty detailed screenshots with the email addresses he was trying to send to. We were able to open up the emails from our end because they bounced back, right? And when they bounced back, they came back and we could see the message because it had bounced, right? So we could see that he was sending himself debug messages through our mail system, which is, I don't know, hundreds of thousands. What are you doing? But it was good evidence to have when we sent it back to the company that they were all shamed actually for having done such a thing to us. But implement a switch so that you can maybe selectively switch off abusers. If you can remove them, right, then you're in a good place. You can say that, okay, Dave, no more. There's no email going out, Dave. You've sent enough. That's something that you should consider. Specifically when you're talking about somebody else who will, interact with you. they will interact with you in lots of very fantastic ways that you never thought that they would. And then this is going to happen. Or, in fact, there's a service for that in Azure. It doesn't hit every scenario, but you could go and use the service API management. It is in Azure. Some people feel it's a little pricey, and you kind of have to fit or hit the sweet spot, really. If you do that, then you could, if it's a match, might as well consider using it. I've used it sometimes, but I've discarded it other times. Depends. But the whole point of that is that it acts as a gateway in front of your service. So you have your service somewhere. It doesn't have to be in Azure. So long as this API management can see it, your service can be on premise. But the general gist of it all is that this is a place where you can throttle. You can put out for application developers that are going to use your service, they can subscribe to it, and you can charge through this service as well. And you can give them a rate. This is how much you can use the API per day or whatever that is. And if they want to have more, they pay a higher premium. So that works really well. Just as a side tip, maybe you don't have to write that code to implement the throttle and implement that stuff yourself. Maybe it's already built, right? It's always a good thing to do. Check if it's already built. But let's go simpler. Let's go to some of the very powerful fundamentals, some of the very powerful basics that I really like. For instance, storage patterns. This might be my favorite pattern of all patterns, because in its simplicity, it's brilliant. So if you have an application and that application needs to fetch some data, you can go to the data store, wherever that is, database something, and fetch the data. It might be that it needs to collect that a view, make a query or something. And that's going to take, it's a shared resource, and that's going to take a little power away from that service, right? Another way to do it, if it's well-known views and things that you want to look at, is to materialize those views in a separate store. Like you could put that in an Azure table or a JSON blob or something like that. Materialize the view somewhere else, and whenever, maybe there's a reasonable tolerance for when the data needs to be updated. So people are changing the data, and from time to time you go and update those views. However often you need to do it, I don't know. But a really good scenario here is to distribute. Yes, the next one is sort of connected to this. The idea here is that you could use this to distribute data around the world. There's another pattern sort of closely related to this first one called static content hosting pattern. If you have static content, a view could be reasonably static. If it's not updated super often, making it a static piece of content is fine. But then you have really static content like CSS files and images and all these things. Those are very static, of course. But what you do with the static content hosting pattern is that you remove all of that static content from your application. You don't host it inside of your application, right? You host it outside of the application on a separate storage. That can help you when you want to deploy something around the world. So I had this gentleman come up to me when I was doing Ask the Experts at Tech Day Sweden 2 years ago. This gentleman comes up to me and he says, we have business in Europe and Australia, and we want to run this service that has a bunch of data that we need to read and also update. And he was showing me his architecture, and we talked through his architecture, how he was going to synchronize databases between Europe and Australia, and files and things. And it wasn't that complicated, but it was nice. He had thought about it, and he was excited, and it was his baby, and he wanted to okay, let's talk about this architecture. Is it good? Yeah, it's good. It's fine. You're going to do well. I have maybe an option for you, and that is to consider maybe how much are you reading your data and how much are you updating. I interviewed him, and same as most, they don't update the data all that much, but they query it a lot. Okay, then I think we have an option here. So we wound up actually doing exactly the materialized view pattern for them. We did it a little bit more sophisticated than that, but the point is that he was able to materialize views for all the querying, both in Australia and in Europe, and whenever an update would come in, it would update the database which they actually placed in Europe. And instead of synchronizing databases, you just had to have one database. And so there were more costs, but basically, just by having an architectural conversation about this, we're able to take down his cost and his complexity in his solution quite a bit. Instead, so we went and implemented this command query responsibility segregation pattern. And that's a reasonably complicated beast to deal with. It kind of looks like this. The gist of it is that you separate querying from commands. So any updates go in a different direction, and all the querying go up here. And what happens when you have a command is that you write it to the real storage, but you also write it to some views that you have updated. So the views can be queried quickly, and the real storage, the database, holds the actual truth. So that's what that is. And basically, there's a lot of talk about this pattern. I don't know if you've heard about it before, but I basically think it's the teenage sex of contemporary software architecture. And you know what something is when you say it's like teenage sex, right? It's like very few people are doing it, and those everybody's talking about it, but those who are doing it are not doing it right. So really, that's what it is, and it's not simple. This is very complicated. So I said we were going to talk about something simple, right? Storage patterns, and I give you this. That is not very simple. So there are a couple of options there as well, and I'm going to unfortunately come back to sounding like I sell things for Microsoft. I really don't. But the SQL database service has built-in geo-replication, right? So if you wanted to handle all of that data synchronization stuff, you can have a master database, say in Europe, and you update that master database based on changes that you put on a queue or a service message bus or something similar. And it's going to automatically synchronize to another database for you. You can synchronize to 4 other databases, so you can have a total of 5 geographically spread out. Doesn't hit every scenario, I understand that, but if it does, how helpful. This literally is point and click on the map in the portal. You say, hey, I have my database here in Europe. I want to have in Australia. Click Save. And synchronize, synchronize, synchronize. OK, well, that's cool. Additionally, Microsoft has another one, right? Cosmos DB. It's pretty cool. I mean, that is a really cool database, multi APIs that you can connect to it, and a bunch of things. I'm certainly not going to go into detail on it, but one thing that they are working on now, it's still in preview. There's a big conference next week. Maybe it'll go GA. I really honestly don't know, but it's multi-master support in that one, which means that if you have your application in 2 regions, say Europe and Australia again, you will have the database in 2 regions. I'm not really sure why this picture shows 2 here, but you will have the database as well in both regions. And automatically, you can do reads and writes locally to that database. They will be synchronized. You can do reads and writes to that one, and they will be synchronized. Automatic synchronization, multi-master. And it's pretty spectacular. Of course, you're paying for twice as many databases, but all the synchronization, all that stuff, it just happens. You don't have to think about it ever. So that can help. If you know that these services exist, you might be able to use them, right? Another one, and this picture is a little weird as well. I mean, what is with all of this whiteness here? It's an odd picture. I think we'll have to put that in parentheses as well. It's the Valet Key Pattern. This is a really cool and useful pattern. You know, valet, of course, super. Do you do that a lot in Australia? Valet parking? You do? They do it a lot in the States, right? Everywhere. We don't do that in Sweden. Okay. Valet parking, anyway, of course, as you all know, works in such a way that you drive up to the restaurant or whatever you're going to, you hand your keys to somebody, and he parks it for you. And that's the point. You could give them your real key to the car, but we've all seen the movies, right? They go like joyriding with your car and drifting and stuff, right? We don't want that. So instead of giving the real key, there is a valet key. Does anyone have one? a valet key, a special other key that you can give to the parking attendant, which only allows them to drive a very short distance, then the car will stop automatically. So that's what that is and how that works. And it's a special key for a special purpose, right? It's a restricted key. And how does that valet pattern come into play here? In a really good way, it turns out. When you have the scenario you want to send files to the service or receive files from the service, what you really shouldn't be doing is pushing those bits through the service. You should go to Azure Storage Direct. And there's a response, and I'm going to describe this in detail. HTTP 302 found. That is a good response. That's your friend. So I'm going to show you how this works. The Valet Key in Azure, they're called shared access signature. Have you used them? You have? Yeah, several people. Very good. This is brilliant. So here's a file that I have in blob storage. And if I go to Azure and browse to this file, I've already done that ahead of time here. And if I browse to my file, I'll show you this file in blob storage. It comes back and actually says 404. Literally what it is saying is that we're not going to tell you if that file exists because you don't have access to it, and I'm not going to say if it's there or not. So you get a 404. Now what you could do to access this file is you could go into this container in Azure and you could set the public access level and make it public. But then the file would be publicly available for everyone, right? Sometimes that's cool, but other times maybe it's not. So what you then can do is to generate this shared access signature. Let's take it from yesterday. It's always good to go back. Oh, that's last year. It's always good to go back a little because of potentially clock drift and things like that. This file will be available until tomorrow. I want read access. You can see how you can set read, write, delete, whichever one you want. And you create this signature. I'll copy the query string there, and I have a notepad ready so that I'll paste it for you and just quickly zoom in. You get this query string thing. This is the key. It says here what it's valid for, and it's also signed at the end. So if I take that key and I attach it to the end of our, zoom in, the end of our URL here, if I do that, paste it in there, and browse to it, I'll get unicorn rainbow butterfly kitten, right? I think everybody needs to have unicorn rainbow butterfly kittens in their lives, so you're welcome. This file is now accessible with this key. If I were to go and change anything in the key, because you see it's signed, if I change the 3 to a 4 there, or actually it's supposed to be 42, right? It's unauthenticated, right? The key is broken, so it's signed, you can't change it. And that's the Valet Key, how it comes into effect. And multiple services in Azure use this approach. And why is that important when it comes to storage again? So I'm going to walk you through how you can do what you can do to use storage for what it's for, not only storing files, but also actually sending and retrieving files, okay? So here's how you would do it if you wanted to upload a file. I have a client somewhere, and I connect to the server, and I say, hey, I would like to upload this file, please. And normally that would mean, hey, here comes the whole file, right? Here's it, I'm streaming the whole thing to you, right? That means that the server needs to read the file into memory and use a bunch of RAM, and then take that file that it has received and send it to storage. You have to shuffle those bits. Instead, what you could do is that the server will validate the request and say, okay, I see you want to send me a file. I'm going to send you a URL with a SAS key, so that you can do with that file as you please. Here's the place I want you to store your file. The client can then send data into Azure Storage Direct. And yes, you can do that from the browser because the Azure Storage supports CORS. Who knows what CORS is? What's the abbreviation stand for? Oh, look at this! A for the day. So many. I had to look it up. Cross-origin resource sharing, right? and it means that you can share resources across domains from your client. The browser won't say, oh no. You configure Azure Storage with the right URL and stuff, and it will accept incoming requests from across another domain. So storage then, when the file is uploaded directly from the client into Azure Storage, well, storage has the ability today to send events. So when a new file appears, it can connect to the event grid, which is another service in Azure, and say, hey, new file. And that can call into an Azure function, that can call into your code, and you can do whatever you need to do with the file to process it. And rather than now sending, half a gigabyte of file into the service, it goes to storage, which is so powerful when you think about it. The other way around, download a file. The client asks for a file through the API, and the server authenticates logs, counts how many requests, and so forth, and then responds with 302 found. It doesn't respond with redirect to another place or something like that. 302 found is a valid HTTP response. It says, I found that file for you that you wanted. It's over there. Okay? So it gives you back a URL with the SAS key, which has read access to the file, which is in Azure Storage. And all browsers and everybody knows 302 found. It's cool. You gave me back this directions, right? Here's the key to get it, and here's the directions. It's over there. I'll go and download it from there. So now we're downloading the file directly from storage rather than actually reading it into the service, into the API, and returning it down to the client. It's a massive change. And I've never so far come to a customer that has implemented something that shuffles files that has implemented that. Never. Okay? So it's rare, but it happens that you can do this, and it's a great pattern to know about because that saves you from running large machines in your service that has to have a lot of RAM because they're shuffling files. Super good. We have some time remaining, which is cool. So I thought I'd go over some sort of more lofty goals. It's not a play on lofty soft or anything, but some more lofty goals, some more like what are you thinking about when you want to do the cloud thingy right? What is it that you need to focus on? These things give you a good map. If you focus on these things, and most of them are also, of course, very important for any other application as well. So they're not exclusive to the cloud in any way, shape, or form. But this gives you a really good set of directions. The manageability part is how you understand the health and performance of your deployed service at scale. Remember monitoring? Yes? You have to understand and be able to manage it. Otherwise, you will wind up adding more instances, paying more money just to have your application run satisfactory for your customers, which is ineffective for you. The throughput is, of course, extremely important because this is about how to increase, operations, transactions, service calls, whatever number it is that you need to count to reduce through your system and then reduce contention. If you can make that happen, you can be more effective, then you can, of course, be able to optimize your resources, right? The density is closely related to the throughput in this case, because how can you enable efficient software systems on as few resources as possible while you are maintaining your high availability and reliability and your users are satisfied? This is something you need to think about and focus on with throughput and density so that you're able to run the service on as few resources as possible. Because when customers are complaining and you really can't find, right now anyway, you haven't yet found what the problem is, what everybody does is up the number of instances. We'll give it more power. More power, Scotty, right? We'll just burn through that money. Not a good thing to do in the long term, maybe necessary in the short run. The availability, of course, is extremely important. I'm going to continue to talk about that right after this list, actually. How to diminish the impact of failures and survive in failure modes and still give a great user experience. The reason why this is important in the cloud is that you are using somebody else's service all the time, right? If you're using SQL database, That's a service hosted by your cloud service provider, Microsoft maybe, right? They're hosting it and running it for you. And it will run, they have an SLA with, 3 nines and a 5 or something. It will run almost all the time. Ever so often, maybe there's a hiccup. And your code needs to be responsive to that and needs to understand this. If it doesn't, you're going to wind up in lots of problems. But this is different from before, right? When you hosted your servers yourselves, you had a server rack in the server room, right? You had an app server rack there with a little label that says apps. And then you had underneath, just immediately underneath there was a different rack that said SQL Server, right? You had a little name that was Martha, the SQL Server, right? You cared for those servers and you loved them. But the point here is, you had a piece of cable this long, right? That goes from one rack to the other. That was the network, right? That was how difficult and complicated that was. You had 100% control of this environment. You don't live there anymore when you're in the cloud. You're using services hosted by someone else. Extremely important to think about this. And then the latency, of course. How do I reduce the time I wait on and wait for individual operations and service calls? How do I make it faster? Well, there's asynchrony for that. So these sort of values, if you will, are things that I try to actively engage with my customers and say, are we thinking about these things? Because really important. As an example of this, how to build a composable system, because that seems to be all the rage now, microservices and all these things. A really good friend of mine made a great quote. He's from New Zealand, so you'll have to excuse him. But he said, building applications today is becoming less about building applications and more about using existing services to bolt applications together. And it kind of speaks to what I said before. If something you need to build your application is already built, you could spend a lot of time building it yourself, or you could just use the service, right? You have to pay for that service, sure, but what does it actually cost to build it yourself and maintain it and all that stuff? Do you have, is it your business to build a service bus, or do you have to use a service bus for your business? Like, you have to think about that. I'm sure everyone here can build a service bus. Give me enough time and money, right? But it's already built. You wouldn't go today and say, hey, you know what? I have this thought. I'm not really happy with our email system, so I'm going to build a new email server, right? I'm going to build a new email service, right? Who would do that? It's called Office 365 or Google Apps for your domain. Nobody does that. And so obviously, you should have the same approach. So a best practice here is, in this scenario, is that you must code asynchronously, and you must handle subsystem failures, which means that you must async await. You have to. So many times do I come in and say, yeah, we migrated this thing to the cloud, and we know it's not doing really well right now. It's a little bit, unreliable. And you go and check the code, and sure enough, it's the old code which doesn't do async await. And, okay, so 2016 called, right? I don't know what to say. Which means that you must retry when you use services. And this is a retry pattern from Microsoft that they have listed. And it's an extremely important one, and actually odds are really good that you're doing it by chance. You're using something like Entity Framework or one of the SDKs to communicate with Azure Storage or similar. They have default retry built in, but you can configure it yourselves, and you probably should figure out and understand exactly how it does retries. So here's the logic behind it. If you send a request to a service, 99.995 times out of all of times, it's going to do exactly what it's supposed to do. And then, that one time, or whatever that is going to respond, yeah. And what do? You wait a little and you try again. And then maybe you try again. And now we've tried 3 times, and that's actually quite a long time, so who's ever waiting for that to complete is somebody who's now getting a little bit impatient. That's why we have async await. It needs to be able to do something else while waiting. Anyway, maybe it returns, sorry, can't fill this request right now. At that point, you have to have your code respond to contingencies. What happens when the service that you're depending on isn't responding the way it should? Do you throw a yellow screen of death at your user? No, you don't. You have to code for that, and I know users hate to get that message, sorry, couldn't save your profile right now, you'll have to try again later. They hate it. But what do they hate more? Yellow screen of death, right? So your code has to be sensitive, I should probably say, to the fact that contingencies happens. So you need to code defensively. You need to know that things will fail. Not, it's not a matter of if they will fail. It's a matter of time. They will fail at some point. And then you always need to do a lot of tracing when you do that. So you have to have that monitoring in there as well. You have to have traces so that when something retries a lot, maybe that's something that you want to be alerted on, right? Maybe you want to know, normally there are no retries. Everything works, everything is good. The response time is good. And then if there's an issue, you'll maybe measure to see, well, all of a sudden the API is really slow. Wonder why it's so slow. Well, then you'd like to know why, and the reason might be that all of a sudden the underlying service, nothing you did, the service that you depend on is slow and it's not responding as it should. So there's a bunch of retries. Well, maybe you want to know that. So that's important to do. We only have a few minutes remaining. I'm happy that I made it so far. I have lots more to oh my God, we could talk all week. We could talk all week, but we're not going to do that because beer. So I have a bit of a quick wrap up, but first I'd like to ask, are there any questions at all? Have I made myself understood, or, is the thing that I'm saying, is it clear? Do you have any questions, thoughts? Oh, you're thinking beer. That's okay. Yes, I have a question.
Maybe other alternatives to monitoring, like Datadog or...
Oh, other alternatives to monitoring. So I don't have the luxury of saying, oh, you should only use Azure or influencing my customers in any way. I have customers using all kinds of logging. But the thing that I can say, many of these products are fantastic, right? I love them, and it's not a problem. It's not about which one to use. It's the fact that they are using one, which is good, and some of them do not. I have one of the examples that I have here in my deck actually is about the customer that is actually logging to databases. And it's like, yeah, there's been so many issues with that, you cannot believe. So they used to log to databases before, and then they migrated to the cloud and built this multi-tenancy service instead, and now they're logging to databases still. It's just a mess. So the point is, you should use whichever one you like, whichever tickles your fancy, floats your goat, and so forth. Use whichever one is good for you. But it has to be one which pulls the data out and puts it in a service and indexes it for you and gives you alert capabilities and all these things. It has to have these nice features, because then you can really fully take advantage of it. And then you use whichever one you like. I know I sound like a Microsoft salesman sometimes. That's okay. Any additional questions? Good question. Yes?
Is there any type of integrated billing kind of monitoring for tenants?
Billing monitoring? Yeah. Oh my gosh, that's a whole topic of its own. We'll talk about that over beers. I can give you a short response. Yes, there is. In fact, I have a whole workshop that talks about these things. So what you do is that you tag your resources in Azure with tags, and then these tags will flow all the way through to the bill. And there are services that you could use to read this and give you nice pie charts and things. You could use Power BI for that. So yes, definitely, to be able to answer the question, how much is development costing, how much is QA costing, how much is production in the US costing, and how much is production in Australia costing, to be able to split and divide, and how much is this customer costing us, all these things. You can definitely get that. The data is there. There's actually 2 APIs, and I'm going to stop ranting about it, but there's actually 2 APIs. One is the consumption API, which is going to tell you exactly how much you have consumed. The other one is the rate card API, which you can call into and say, okay, I have consumed an hour of SQL database, and I have this subscription. What does that cost? And basically, you could do it yourself, but again, don't do that. It's been built. So yeah, that's a great question. And when the bean counters come running saying, hey, the Azure bill keeps going up, it's more and more expensive, how can you motivate and tell? You need to be prepared for that. It's going to happen. And there's ways to do it, yes. I think we're actually coming to a close here now. So I'm going to give you those two. Those are the locations. You've probably been there already, but it's worth going in there and spending time. Read through the pattern list just once. And then the Architecture Center has so much architecture. Oh my gosh, so many examples of building different things. I think they've done a really good job here. These are links to Azure documentation. And if you need to learn about, there's 150 services in Azure. If you need to learn about them, they also have this one additionally, the Microsoft.com Azure Essentials. Bite-sized training, right? So it's small. It's like it's like an hour or something. It's very, very condensed, so you can learn about various services. If you have an inkling that maybe this one is something we need, you check it out in the Architecture Center and say, hey, we maybe need to use Service Bus. We've never done that. Odds are really good that there's an Azure Essential for Service Bus, and you can go at least get a baseline understanding about it. So, people, friends, in the cloud, you pay for what you use. In the cloud, effective architectures take full advantage of the multitude of services. And in the cloud, your code needs to work when somebody else's service does not. I'm going to leave you with a nice picture here. This is an anti-pattern that I have sort of dreamt together myself. This is, of course, Wile E. Coyote. But the anti-pattern is almost flying in the clouds. Okay, so what does that mean? It means that you don't have to take everything you have and put it in the cloud. You don't. But if you have it on premise and you say, we're migrating this to the cloud, and then you start migrating stuff, you have new customers coming in and they use the cloud version, but you still have your old customers and they're using the one on premise. And you don't want to upset your old customers because they're currently paying for all the new development you're doing with the cloud. And the longer you stay in this limbo situation, the more assured you can be that you will fall flat on your face. So that's the final words that I have for you. Think about that. Try to actually, if you're migrating something to the cloud, actually get it done. Finish it. At some point, tell the customers you have on the ground, on premise, tell them, no, you must now move to the cloud. This is it. So those were my final words. Thank you very much for your attention. In case you want to have a workshop, there's one that you could get me to come and deliver to you. The 2-day workshop about how to become a wizard of managing Azure resources. Thank you for attention. Go and have beer. Thank you very much.